In this video I'm going to look at breaking up a rational expression into partial fractions. The example we're going to look at is x plus 4 over x squared plus x minus 2. Now we want to express that as partial fractions, so the first thing we've got to do is factorise the denominator. Now factorising the denominator, we get our expression equal to x plus 4 over x minus 1 times x plus 2. That's just a straightforward binomial factorisation, and you can see some of the other videos on how to go about doing that. Having expressed it over its factorised denominator, we now need to break that up into the two partial fractions. So I'm going to write it as a over x plus 1 and b over x plus 2. So these are equivalent statements. X plus 4 over x minus 1 times x plus 2 equals a over x plus 1 plus b over x plus 2. We need to think to ourselves now that we are going to multiply both sides by the common denominator. And the common denominator in this case is x minus 1 times x plus 2. Multiplying out, we can see that on the left-hand side of our equation, the denominator just cancels out. On the right-hand side, only part of each denominator cancels out. So we're left with x plus 4 equals a outside of x plus 2 plus b outside of x take 1. Now here's the tricky step in partial fractions. If we look at the expression on the right-hand side, we can choose suitable values of x to make each of the bracketed items equal to 0. For example, if I take an x value of x equals negative 2, then we can substitute that in the equation. We get negative 2 plus 4 on the left-hand side. And on the right-hand side of the equation, we get a times 0, because negative 2 plus 2 inside the brackets equals 0. So the term with the a drops out. And keeping on with our substitution, we get b outside of negative 2 minus 1. Now that, of course, allows us to solve for b. We can see that collecting the terms on the left-hand side, we get plus 2. Over on the right-hand side, we get b times minus 3. Just swinging the negative 3 over to the other side, we can pretty quickly see that b is equal to negative 2/3. Similarly, if we choose a value of plus 1 for x in our original equation, we can substitute that into the equation and the b term will disappear. Substituting x equals positive 1, then we get 1 plus 4 on the left-hand side. On the right-hand side, we get a outside of 1 plus 2 plus b times 0. And a quick rearrangement of the equation will get a value for a equal to 3/5. So our partial fraction then can be written as x plus 4 over x squared plus x minus 2 equals 3/5 over x plus 1, substituting back for a, minus 2/3 over x plus 2, substituting back for b. And just tidying that up a little neater, we can see that we get x plus 4 over x squared plus x minus 2 equal to 3 over 5 outside of x minus 1 minus 2 over 3 outside of x plus 2. And that's